Okay, so we've done Newton projections, and now we're going to kind of look into how do we apply that to some more interesting types of questions and concerns, right? So the first thing I want to do is I just want to do one more example of a Newton projection, a type of question you might see with these. So let's say that you have this compound. Right? I'm going to call this one carbon A. I'm going to call this one carbon B. And we want to draw the most stable, so draw the most stable Newton projection of this molecule. All right, so first of all, a Newton projection is the thing that we've been talking about, right? Where you have the front carbon and the back carbon. And so drawing the most stable one, we know that we want to draw a staggered one. So I'm going to go ahead and draw a staggered version of this, and then I'll allow you to maybe pause the video and fill in each of these positions, right? So remember, carbon A is the front one, carbon B is the one behind. We have three groups attached to carbon A, plus the connection between carbon A and carbon B. We have three groups attached to carbon B, plus the connection between carbon B and carbon A. So figure out what the ones are on A, figure out what the ones are on B, put them onto this Newton projection, and then figure out what the most stable position is. Okay, so now is the time to pause the video and then come back when you're done. All right, I'm assuming that you've come back, or else you cheated and just kept watching, which I guess is okay because I sure can't tell the difference. All right, so I'm going to start putting on. So from carbon A, we have a chlorine, we have a methyl group, and then we also have a hydrogen. Right, that's the other thing that's there. So I'm going to put the methyl group here, the hydrogen here. Okay. On carbon B, we have two carbon groups. We have the isopropyl group, which is here, and we have an ethyl group. So we have a CH2, CH3. And then on carbon B, we also have a hydrogen, which wasn't shown, but we know it's there because we're good at reading organic structures. Okay, so now we've got all our groups on. Now what is the goal, right? We said we want the most stable. What does most stable mean in a Newton projection? It means we need to orient the large groups. Okay, 180 degrees from each other. So what are our large groups? What's the largest group on carbon A? Remember, when we say large group, biggest group, we mean the one with the most sigma bonds. So that's going to be this CH3 group. Right? So the CH3 group is the largest group that's attached to carbon A. CH3 is larger than Cl, it's larger than H. On carbon B, which is the largest group is going to be this isopropyl group because, again, it has the most sigma bonds. So notice that even though the ethyl group is larger than the methyl group, it doesn't matter because we're just looking at what are the large groups in carbon A and what is the large group in carbon B. And then once we know that, we orient them 180 degrees from each other. So I'm going to rotate the front carbon again. I'm going to move this one up here because that will put it 180 degrees from the isopropyl group. And that means that everything else is also going to rotate 120 degrees. So we're going to get methyl group straight up. The chlorine got rotated over here. The hydrogen got rotated over here. And all the back stuff stays the same. This is the anti-conformation of this molecule, right? The one over here that we started with that I drew at first is gauche. And so oftentimes what you'll end up doing is you'll draw a structure and then you'll say, oh, my large groups are next to each other. This is gauche. I need to move to the anti one, right? Sometimes you'll get lucky and you'll draw the anti one straight away, but you can just rotate everything, right? So the methyl group, if this wasn't clear, the methyl group rotates up here, the chlorine group rotates down here, and the hydrogen rotates over here to take the place of the methyl group. So everything just moves 120 degrees to get there. Okay? That is the anti-conformation.